So welcome friends to our next edition of IIT-JEE questions. The question is, if cosec inverse cosec x and cosec of cosec inverse are equal functions, then the maximum range of the values of x. These are the four options. So what we need to know, there are two different types of function. One is cosec inverse cosec x. So this will be taken as inverse function. This will have certain value. So ultimately cosec inverse x gives you an angle. The range for cosec inverse, as it is known to you, is minus pi by 2 to pi by 2 excluding 0. So you can write down it's minus pi by 2 included to 0, 0 excluded, because at 0 it is infinity, union 0 to pi by 2. Now, other function is cosec function, cosec of cosec inverse x. For that we need to apply the concept of trigo. This one is trigo. So trigo function cosec has range real number except all the values lying between minus 1 and 1. Now we'll take them on number lines, which will be like this. Left side not defined, that is minus infinity. Right side also not defined, infinity. In between we have 0, then we have minus 1, then we have 1. Minus pi by 2 is smaller than minus 1. When we put pi equal to 22 by 7, we can easily obtain that pi by 2 to the right side. First apply this one, the value between minus pi by 2 to 0. This minus pi by 2 is included, 0 is not. The other one 0 to pi by 2. So this is the range of the first one. The second function, which is trigo function, has the range all the real number except minus 1 and 1. This can be shown in this manner. Minus 1 included, the other one 1 to 1 included, and infinity included. Now since they are equal, we will take common point. Common point is this one and this one. So the result is minus pi by 2 to minus 1 union 1 to pi by 2. Therefore option A is the right one. Yes. One of the most commonly used concept is arithmetic mean is greater than equal to geometric mean. So to use that, first we need to simplify this expression. That is, this one is 2 root 3, so take 2 common. We are getting root 3 minus 1, then this x square. Now x square can be taken common from the denominator, which gives us x square plus 2 plus 3 upon x square. Now this x square and x square gets cancelled. Now this is the part basically which we want to analyze with the help of arithmetic mean greater than geometric mean, because the smaller is the denominator, bigger is the value. So we will say x square plus 3 upon x square divided by 2. These two numbers arithmetically will be greater than equal to x square into 3 upon x square and then square root, which on further simplification gives us x square plus 3 by x square greater than equal to 2 into 3 raised to half, that is root 3. Means this x square plus 3 upon x square is always greater than equal to 2 root 3. We want x square plus 3 upon x square plus 2. This will be naturally greater than 2 plus 2 root 3. We have added 2 both sides. So what we can say, as I already said in the beginning, this function will have maximum value if our denominator is minimum. Numerator, we can't do anything about this. This is okay. 2 into root 3 minus 1. The minimum value of the denominator is 2 into root 3 plus 1. So 2 gets cancelled. This root 3 minus 1 upon root 3 plus 1 is basically the value of tan theta for 15 degree. That makes option B correct. In this question, as you can see, this is about permutation and combination. In a room there are 12 bulbs of the same voltage and each having a separate switch. The total number of ways to light the room with different amount of illumination. So first we will try to understand what are the possible number of illumination. One bulb can give you illumination in two different ways. Two different ways. One is on, another one is off, right? Now, how many bulbs we are having? 12 bulbs. So 12 bulbs can give us illumination in 2 into 2 into 2 into, and this way, since we have 12 bulbs, so it will become 12 times. So that gives us 2 raised to 12 ways of illumination. Now, these are the different possible, these are the possible illuminations. All the possible illuminations, which obviously includes all the possible cases, like they are all on, they are all off, you are on, you are off. Now the question is asking about different amount of illumination. So what we will do, we will subtract from this those cases in which we will have same illumination. So same illumination will be in just one case. And therefore, the different illumination will be obtained by 2 raised to 12 minus 1. This one which we have taken is basically when all are on. Off will not be taken because that is not giving you any kind of illumination. So this way, option number C. Okay, so looking at our next question, there is a set A which contains n elements. The number of triplets, this is what we have to form. So we have to basically form the sets which are having 3 elements, in which at least 2 coordinates is equal. So first, we'll see in how many ways we can fill the 3 places. We have n elements, so first place can be filled in n ways, second also in n ways, and third also in n ways. So this way it is n into n into n, that is n raised to 3, which obviously includes all the possible cases, like distinct, 2 different, 2 same, 1 different. So to find the number of cases in which we have at least 2 coordinates equal, 2 coordinates equal. We'll subtract when all are different. We subtract when all are different, then obviously we get like these 2 are same, one case these 2 are same, and then first and last are same. So this will be easier, just directly remove when all are different. So using this concept, we have n things, out of which we have to take 3 at a time for the element. So NP3, the formula NP are of permutation. So required result will be therefore N cube minus NP3, and therefore option B is the option. We supply 7 square is equal to 49. This 49 just compared to 25. The closest multiple of 25 when we compare of 49 is 50. So our target is to obtain 50. We proceed. 7 raised to 103 can be written as 7 into 7 raised to 102. That gives you 7 square and 51. Then this one is 49, which can be easily written as 50 minus 1. Now this question is solved by using this binomial, which is starting with 51 C0, 50 raised to NCR. First one is having power n minus 1, so that is giving you 51. The next one will be minus, alternatively positive and negative. 51C, 50 raised to 50. So all are containing 50. And this way, the last term will be 51C, 51. Obviously with negative sign. Now, all the terms are containing 50, so they all are divisible. So we can write them as 50 into something or 25 into something. Means they are factor of 25, and then this one is the remainder, minus 1. Now we are dividing by 25. Say this one is represented by E. When we divide this one by 25, this part 7 into 25k gets completely divisible, and then we are left with this 1 upon 25. Now to deal this one, we need to know this one is equal to, this one is 7 into 1, sorry 7. This one is expressible as 1 minus 18 upon 25. 25 is bigger number, so obviously division will be like this. The remainder is never in negative, it is always positive. So to get that positive result, we need to make adjustment with 1. 1 minus 18 upon 25 gives us 7 upon 25. So 7k minus 1 plus 18 upon 25. So this plus 18 is basically the remainder. Remainder will be 18. Okay. So that's all for this edition. I will come with few more challenging questions in our next edition, like I have done in my